Good afternoon, all of you. Topic is S.M.P.S. S.M.P.S. Instead of using L.P.S., most of are using S.M.P.S. S.M.P.S stands for switch mode power supply. It takes switching to regulate the power, voltage or current. LPS is using a transformer, filter and voltage regulator or power regulator circuit, where the S.M.P.S have some fundamental design. S.M.P.S switch mode, the switch or state is on, or then the device will heat. But when the switch is off or state is off, then the that device will cool down. So this is heat dissipation is less in S.M.P.S. So due to this heat dissipation, the efficiency is more. So LPS is 30 to 40%, where the good design of S.M.P.S can have efficiency of 90%. LPS means linear power supply, whichever we have designed in the SAM, it was LPS, and for that regulate the voltage by dissipating it. Like we are giving input 12 volt and 5 ampere, and we want output voltage of 5 volt and 1 ampere. So the additional 7 volt will be dissipated by the heat. Due to its heat dissipation, its efficiency is too less. So the switch mode comes in the picture.
You can full screen the
this is a
presentation.
Hello.
What? You can full screen the presentation, if it's okay.
Oh, okay. Sorry. Next, understand how the S.M.P.S is working. First of all, we give the AC input with a 50 or 230 volt AC signal or voltage, and after that voltage will be rectified as filter and converted into DC voltage. Like 230 volt AC is converted now into 230 volt DC. After that, converted DC voltage is given to switching device. Here, a MOSFET is used as a switching device. That switching device will convert that high volt DC into the high frequency pulse wave, pulse signal. After that, given to step down transformer, and that will step down the voltage into some honest voltage, like 24 volt or 12 volt or whatever we want. After that step down transformer, the rectified and filter comes, because that was a pulse voltage, and that we have to convert in DC. So rectifier and filter will do that, and we get DC output. But after we again take feedback, and feedback voltage is given to the isonator, because here the high voltage and low voltage are to both working in one circuit. So we have to isolate because if to protect the high voltage low voltage circuit to the high voltage circuit, so to protect that we have to use isonator. That after that isolated signal is given to the error amplifier, means comparator, and it will compare with the reference, means whatever we want output, it is a reference voltage, and it will compare that we want 12 volt and we got it or not. That that reference and we got a comparison that will give to the PWM control unit, and this will set the pulse of the pulse width of the switching, and that give to the switching device MOSFET. Here the working of the S.M.P.S. AC input with 50 Hz frequency square convert high voltage AC to after filter noise and convert
Kartavya,
into
you can skip the
yes,
details if you want to.
and most of S.M.P.S uses switching device to to make say square wave, and square wave signal is transformer. That square transformer will convert high voltage DC to low voltage, and that reduce DC voltage given to again rectifier and filter, and this an isolator will isolate the voltage and low voltage side, and that given to error amplifier is filter, and it will reference voltage, it will set the pulse width of the square wave and give to the MOSFET. You can see this is a functional block diagram of the S.M.P.S. Here is a rectifier. After here LC filter is used to to remove the noise of the DC voltage, and after that DC voltage high volt DC is given to MOSFET. This high voltage is DC given to the drain pin of MOSFET, and the gate pin of MOSFET is inputted with the and at drain at source pin we will get square wave, and that square wave given to transformer, and that it will step down the DC voltage, and again the rectifier will convert into the pure DC voltage, and will remove the noise. Here we will get output DC voltage. Here as a isolator octocop, and this is as a PWM control unit. We will use a microcontroller or something. This is a size comparison S.M.P.S and L.P.S. You can see L.P.S a very big transformer, where the L.P.S a very S.M.P.S a very small size of transformer. Here the big capacitor is used, because you can see high voltage DC signal, the capacitor is used. Uh, because here the voltage is too high, like 230 volt or 260 volt. So to store, to handle that high voltage, here a big capacitor is used. Otherwise, is of a transformer is concerned, so here it is reduced. Here one IC is used, TNY 268. This is a hidden control unit circuit, and this IC have inbuilt MOSFET. Here is one. Here you can see some transformer like something. This is a you can see this is a inductor here, and also this side inductor here. This is a called it removes the noise from the AC voltage. So this is a S.M.P.S small circuit. Advantage of S.M.P.S. So we can achieve very high efficiency in this S.M.P.S, and it have more power handling capacity than S.M.P.S. Like LPS, if we give more power to LPS, it will dissipate the heat too much. Here the S.M.P.S can handle up to 1 kilowatt or like around, and here you can reduce. So one more advantage, and the cost is no. Cost is no, because the here cost is of transformer. Here if you buy a transformer for the LPS, it is around 200 or 300 rupees, where the S.M.P.S transformer is around 50 to 100 rupees. So reduced when one another point is it gives isolation, where LPS can't provide isolation. Here whatever we get, the in the LPS isolation is not required, but in S.M.P.S both side high voltage and low voltage side is in the one circuit, so isolation is required. So it provides isolation. So this is advantage of S.M.P.S. So its design is some complex, and we are using high frequency, like 100 kilohertz or 300 kilohertz. So noise comes in picture. After the component are not easily market. Here in the S.M.P.S we are using MOSFET, PWM generator signal, choke filter, rectifier, and this transformer. So a MOSFET and this transformer are not easily available. So how this is we can achieve this high.
Okay.
How can we this S.M.P.S main concern? Why using high frequency, and why the how the transformer size use? Anyone can question? Any yesterday, one sir asked me one question. Why the transformer is not uh, is not before the rectifier. Why we transformer after this MOSFET? So here the main if we wait here is the how this is possible. The frequency is main hero of this S.M.P.S. If we increase the here are two formulas. First is numbers of turns in the winding of the transformer, and the another equation is mutual inductance, which will induce the voltage in the transformer. These two equations, first of all, are numbers of turn equals to mutual inductance into current upon B is flux density. It is a different for different materials, and the core area A is core area, and is equals to V in square into duty cycle of the square wave upon into 2 into input power. So if we
Kartavya,
increase the yes,
you can skip the derivation. You can just say the conclusion, I guess, because some of them
um,
don't get it, I guess.
yes, it is coming. If we increase the frequency, the mutual inductance is reduced, and the mutual inductance is reduced. The core area is reduced, and the mutual inductance is reduced. Numbers of turns is reduced. So that's why the size is small in this of this S.M.P.S transformer. Now got it?
Yeah, okay. So the frequency basically plays the vital role for the size.
Yes.
Okay. So that's a very deep understanding of S.M.P.S, I guess. Thank you very much for that. If anyone wants to ask questions, they can. Yeah, Dhyanam, pushed anyone?
No, there's no question.
Okay.
There's no question.
Okay.
Good. Thank you, guys.
Okay. One suggestion for you.
Thank you, Kartavya.
Okay. One suggestion for you, Kartavya. So just
Yes.
don't go in detail much if it's possible, because like if you're presenting in front of the non-EC guy, then he will probably not understand the everything, like the equation and what. So just pick the analogy, like what they can understand in general. Okay. If they
Okay.
ask,
Okay.
then you
Got.
can tell in detail. Otherwise, you can just go on brief.
Okay. Okay.
Okay. So we'll move on to next one.